1 2 1 2, mic check, mic check. I think we are all good and working. Let's just check the stream has started. Stream connecting. Nice. Cool. We are cooking on the internet. Hello everyone. Hello future viewers of the VOD. Feel free to skip forward a bit for the content because we're just starting off the stream, getting a few people in the live chat, and yeah, we're joined with Sinewave02 today. We're both doing a bit of repair work, both doing a bit of soldering, and yeah, I thought it'd just be nice to have a little catch up and see what's going on. On the bench today, I have a couple of bits. I'm looking at actually one of the very first amplifiers that I learned to repair on, not the same exact same board, the same one, but the same model. This is the Viking 7000. So these amps are the reason that I got into doing amp repair, was these amps, because I was selling these in the UK and a bunch of them failed, and so I was either stuck with them or had to send them back to Brazil at my own expense, or I thought, you know what, I'll just try and fix them, I'll learn how to fix them. So this is what got me into amp repairs, these amps. How's it going, everyone in the chat? Happy Halloween, everyone. Hope you're doing well. So, Sinewave, Mr. Donnell, what do you think about the base phase Team Red 15s then, from your experience so far?
Do you know what? I'll be honest, from 300 subs, yeah, I'm just messing around them, inbox, outbox, they hold their own really well. They've got really good dampening on them, I think.
Okay.
That mechanical dampening, I think, is really pretty good on them.
I think you were saying, is that the impedance rise is really high on those?
Yeah, it's really high, but just like, normally you 300 sub, and for very little power you put in, you can bottom out. With these, they hold their own pretty well.
So I'm going to be putting them in the van for sure, to sell it with. I'm just going to sell my Z415 motors to probably someone in Europe or something. So yeah, I was just hoping that they were going to perform alright in the van for the new owner. Sinewave mic,
I'm sure they'll be
bad and distorted. Okay, let me just sort that out. Hey, Sinewave, do you want to just do some chatting and I'll just calibrate your mic a little bit?
Yo, is it my mic or is it the stream?
No, it's my volume. Like, you're coming through my speakers and it's going through the camera mic. So hopefully that's better. I've just turned the volume down, so hopefully your voice is better. Keep me updated, guys, on how his voice is, because I can't like hear it from your perspective. So.
Yo, Swell, how's it going, bro? Right, I need to get some stuff. I think I might pop these side plates off. Sitting down.
So Sinewave02 today is doing some repair on a Vibe M21K, which is a Korean full bridge design. They're terribly volatile, they blow up all the time, and he's doing a driver card swap on the output section between two of the boards to save having to do surface mount soldering and all that. Better, but we still have an echo. You shouldn't have an echo. Why do you got an echo? Because all you should be hearing is... All you should be hearing, the only active sound thing is my microphone.
Damn, mute yourself on Discord.
That's very strange. The only active sound device in OBS is my microphone.
Yeah, go on Discord and mute yourself.
Oh wait, hang on, I think I just figured it out. There was one called Osmo Mic that was actually for some reason new, so that should be better now. How's that? If you say something now.
Yo.
Okay. And just talk us through what you're doing on the repair so I can calibrate your audio level.
Yeah, so basically I'm going to swap out the driver card on this board here.
Okay.
So you've got...
I think that's better.
Well, the driver card's not actually in it. The driver card's not actually in it because it's on the bench. But I've got another M21K that I've got to break up and basically do that.
But you see when the driver car goes there, it's just going to go straight in, and hopefully this one fires up. There's no blowing output or anything. So, yeah.
Cool. Awesome.
We could use hope for the best.
Well, I wish you luck. Like I said, I'm currently doing a Viking 7K, and I don't have the parts for this yet. The parts are out for delivery today, so maybe during the stream the parts will arrive and I can fit these. Like I say, these were the first amps I ever learned to repair on. If you, in the live chat, if any of you guys do amp repair yourself, what was the first make model of amp that you learned on, or what was the first one that you kind of took on as a challenge and gave you some confidence to carry on doing repairs?
Right. Cool.
Hey bro.
Hey
bro, I have a Fosgate Power 800/4 that was brand new, sat for years, and then when I connected it up, it has an issue on one channel. If it has an issue on one channel and it was sat for years, it's probably just the physical toggle switches that have got a bit of oxidization on the contacts. So spray some isopropyl or some contact cleaner into all of the toggle switches on the amplifier, flick them back and forth 20 to 30 times, and just see if that solves it, because when amps are sat like that, it builds a bit of a layer on the switch contacts. So give that a go first. If you still have problems, I can look at it for you if you're based in the UK. If you are based in the UK, shoot me a message on my BearVids Facebook page, facebook.com/BearVids, and I'll get back to you there.
I'm just going to sit on the desk and break this down. Well, why not?
Them, the clips are kind of tricky, aren't they, on those ones? They're very stiff, those ones.
I'm probably going to pin them off into my screen very well.
I've done that multiple times. I've got some dents in my screen from that.
Yeah. Maybe if I point you guys down, you can see. Somewhat.
These Band of Viking boards actually have pretty decent thermal mass. Like, they're some of the higher thermal mass boards that I've come across, especially coming out of Korea. Yesterday I started on my first Class D. Wow, that's crazy that you're starting on Class D. Now, like, pretty much all amplifiers that I repair are Class D. It's a rarity that I ever get any Class AB come in. It's a very different process to diagnose and repair Class D than it is Class AB. You need a different skill set, different set of troubleshooting skills.
One of my YouTube live with still on, let me see. Ah, this thing get that hot? How do I get it off? What have I got in here? This thing's on there good.
The power supply side of both amp classes are the same. Yep. Yeah, power supply sections in like car amplifiers are all 99% just close, just the same basic circuit. Apparently, this guy did the scuba diver did amp repair in school. That's pretty cool. Like, I never would have had the opportunity to do amplifier repair in school.
Yeah, that would have been sick. Oh, I forgot about this amp smells. Oh my god.
Right, what I need to do is power this up and just see if the drive circuit survived. These Band of Viking amps, when they fail, it's literally always one MOSFET and that's it. And it's very tempting just to change like the two FETs in the bank from the failed bank, but the current sharing between these banks is very sensitive. So if you just change the two FETs here, for example, for new ones, then they either contribute almost all the power themselves because their RDS is lower, or if the RDS is slightly higher than the other banks, then they don't contribute at all, and then it kills one of the other FETs in the other bank. So when you're doing these, you've got to just replace all 8 FETs for the exact same batch. It's really annoying.
Can't like the Allen key method. God tier.
Yeah, it's good, isn't it? It's funny, this is basically a 4-channel amplifier. This Band of Viking mono, this is essentially a 4-channel amplifier in terms of the output stage. It's 4 separate output stages, but they all just share an input signal basically. These two are flipped from these two in polarity, so that it's full bridge. But yeah, it's essentially 4 separate channels. If you modify the circuit a little bit, you could essentially, you added extra filters, you could essentially turn this into a 4-channel, what would it be like? About 1800 watts per channel into 4 ohm. Jordan's going to paste an interesting text message in the comments. Nice. I look forward to seeing what that's. It's probably blown this stuff up. I did 3 years of electronics in high school, and they didn't teach electronics in my high school. Mostly TVs and other home electronics. Nice. We tried out your speakers and they are so awesome. However, with the top down and the tailgate shut, they started smelling like smoke. Nice. Gonna have yourself a recone kit on the way, I think.
Do you know what I was really impressed about, and I only clocked it from your video, bro?
Yeah, what's that?
You know the bass amplifiers, how well they come apart. Like, you just lift out the whole thing.
Oh yeah.
It's better than doing this.
Yeah. Those clamps are kind of peak.
I'm getting through them pretty quickly. I don't know how these burnt ones are going to come out there.
No, they come out the same. They don't really get affected. Right, I'm powering up this Band of Viking thing. These amps are strange. They make a funny sound when you turn them on. They go. It's the duty cycle of the power supply increasing.
Touch wood, so I ain't shot my screen yet.
Nice. There we go. Okay, so we got to check for. Ooh. Okay. Yep. So we're checking for low side drive.
Yes.
And the bank that failed was this bank. So I'm just going to shove my probe in this bank here and go for a full power up. Okay, so we got low side drive on the bank there that failed, and if I AC couple the scope, you can see there we have that is what the high side drive just looks like on these. It kind of bounces in and out. That's fine because it doesn't really have a voltage reference for the high side. It's got just enough to provide a little bit of drive there. So if you're working on a Band of Viking and you don't have FETs fitted, low side looks like this, and the high side you do actually get a little bit of waveform. Most amps don't give you anything on the high side without MOSFETs fitted, but these ones you do get a little bit. But if it bounces like that, that's absolutely fine. That is perfectly normal. So yeah, this amp drive circuit survived. It just literally needs FETs, and they are on the way today. So hopefully they arrive and I can fit them today. That'd be cool.
Hey, these burnt ones these are on their good son.
Yeah. The Band of Vikings actually have a design flaw. An oversight. So basically this little circuit right here, which looks a bit cooked, get that focused a bit, there's a little circuit right here, and what happens is when you remove the remote, when the remote voltage disappears, this transistor turns on and it dumps the rail voltage from the rail caps through these high value resistors through this transistor to ground to dump all the rail, so that the rail voltage disappears very quickly. But these resistors were not spec'd high enough power. These are just little surface mount resistors, and these absolutely cook. Every time you turn the amp off, these absolutely cook. You can see they just completely fall off to pieces here. So what I usually do is I'm going to remove all of those and just replace all of these with a single high power resistor, rather than all these little surface mount guys, because they just burn. Like this circuit isn't really required, the only reason that you want to dump the rail voltage to ground, well, actually there's a couple of reasons in this instance. With an amplifier that has dual rails, positive and negative rail, there's no real reason to dump the rails to ground. It only makes it safer if you're taking the amp apart and working on it, because otherwise, if you don't, then the rail caps can still have like dangerously high voltage in them, 200, 300 volts plus in a big amplifier, even months after you last powered it off, and you never expect that. So if the user tries to take the back off and starts fiddling around, there's dangerous voltages in there. So pull down resistors are a good idea for that reason, but in terms of how the circuit works and the circuit's own safety, it's actually better to not have them, because the power supply then doesn't have to build the rails every single time you power it up. They're already there, so there's less energy to put back into the caps. But in the case of single positive rail amplifiers like these ones that just have a single positive rail, and then the audio swings between a midpoint between the ground and rail, these amps have half rail on the speaker terminals at all times. Some of them do, depending on the design. I'm pretty sure that these Banner Viking do. So because of that, when you power the amplifier off, there is still like pretty high voltage on the speaker terminals, DC on the speaker terminals reference to ground, so you don't want to be touching that. So you do kind of need the rail voltage in these amps to dissipate to ground relatively quickly after powering them off. Why live chat now shows the ID instead of the name, I have no idea.
I'm like a sloth trying to get this amp apart, man. The screws never come up the board. You have to kind of pull the screws up.
I'm so tired, guys. Jesus, I'm so sleepy. Not been sleeping great the last few nights. What's going on here? Breakfast! Jordan, you got to lower the gains if you lend out your vehicle. Yeah, I would do the same. I have never lent my vehicle out to anyone that I can remember. Not a vehicle with a system in it anyway. And if I did, I'd either just take the head unit faceplate off, or disable, like remove the remote from the amp, or just like lower the gains down.
What can I use to get?
It's 3 AM there. No, it's not 3 AM. It's 12:11 in the afternoon. It's lunchtime. Man's gonna get some lunch soon. You've no idea how much you've helped me. I can now fix many amps, and when I'm on a deadlock, I always check your vids. Man, this is literally the reason I did the videos. Literally the reason I did videos. Comments like this from Jimmy here literally makes it all worth it. That's the reason that I decided to start making amp repair videos, was so that other people could learn, and it feels good. Because not enough people in the world are doing component level repairs, so we need more people doing them. So if I can convince even a handful of people to start doing component level stuff, because doing component level repairs, yeah, it's not just giving you a skill to do component level repairs. It's giving you so much troubleshooting and problem solving skills that you can apply to other areas of life, not just electronics, but also mechanics, and also, I would say, because fixing electronics like this, it's logical. You look at where the problem area is, and you work out how that happened, and you work out, you go back from there to work out what else it's damaged, or you work out what caused it, and it's very logical. And having logical problem-solving skills is actually a great skill to have, not just for repairing physical things, but also for solving problems in elsewhere in your life, like mental problems, relationship problems, anything. Like having problem-solving skills does translate between physical problems and like human problems. So
this board got done up different. Then these guys can see that.
It's no big deal to me. I just let them use it last year. It's a young couple, and she's a DJ, and they put her setup in the Jeep and ride around like a mobile DJ. That's jokes. I want to do something similar with my jumbuck. I've got a Proton jumbuck now, which is a little car-based pickup, and I'd love to like trick out the back of that with like a sound system and a DJ setup. But we're not in a country where I could drive around and have a DJ like spinning tunes in the back while I'm driving, because some countries you'd probably be alright with that, but not here. Those subwoofers are really old and have been abused, so it's possible they just finally died. Not your fault if they did. That's valid. I mean, it definitely is their fault if they smoked out, but that's a very generous message, and to relieve them of any stress they might have from being like, oh my god, we killed his setup. Like, They did, but they're not going to be stressing out about it now after that message. That's really nice. A little underseat sub with a small stunt wall in the back, and I see stunt walls don't really go down well in the UK. People don't like them. They're obnoxious.
Can't focus.
Right, so I'm waiting for parts on that Band of Viking, but excitingly, I do have some parts finally arrive for an amp that I bought myself. I bought an amp to fix. I want to say it came from Portugal. I could be wrong, but it's a Taramps HD15K. I've already got one of these, but this one I think is a 2 ohm version. Scary high rail voltage in these, and it had a pretty catastrophic power supply meltdown, and it needed new rectifiers. So I think I've finally got the rectifiers come through, so we can get it up and running again. Hey, so here we go. Here it is. Oh yeah, that was cooked. Yep. There we go. Have a little peek at that. Now, is this a 2 ohm version? Let's have a look. It usually has a little marking on the board somewhere, if I remember rightly. Yep, 2 ohm version. So this has the same internal voltages and the same. It has the same kind of circuit architecture as a 30K amplifier, 1 ohm version. 1 ohm 30K amp would do, but obviously it just doesn't have. It has got half the number of parallel components because it obviously can't make 30K. So it's a 15K 2 ohm amplifier. It needed all new power supply FETs, and these are the relatively expensive beefy IIF P4004. There are other options that I could have put in here, but I was doing some data sheet, like looking at the data sheets and stuff, and these weren't really that much more. They were a bit more expensive, but they weren't that much more expensive. So I thought, might as well just get the big boys. So all it needs now is rectifiers. So the output section, interestingly, these Taramps HD series amplifiers with the IGBTs in the output section, the output sections are actually immensely reliable. When these amps fail, it's always the power supply sections. And I noticed that there is actually a design flaw, as a glitch with the MCU here. When you initially apply the remote to the amplifier, or is it when you power it off? It's one of the two. It's when you either apply or remove the remote. I'll find out in a minute. It sends a very, very small pulse to both banks of gates at the same time, so it turns the FETs on, like both at the same time, for like a fraction of a second. And that's like getting a power and ground cable and going like getting a spark, but it's doing that through all the power supply FETs. So I think that over time they just get weak from that and they fail. But in this case, that doesn't seem to have happened, because the cause of the failure was actually the rectifiers, it seems. Now, the rectifiers can fail from overcurrent through the rectifiers because of an output side short, but there's no output side short. The IGBTs are fine. I don't believe the previous owner had like a shorted voice coil or something. So I wonder whether the rectifiers just were under-spec'd in this, or the batch was bad or something and they weren't up to the job. They failed and took out the power supply. So I have some replacements here. I think I upgraded them a little bit with the spec. Cargo says, thinking theoretically, if you slap some bigger boy FETs in there, could it do 30K? No, so the reason it can't do 30K is the transformer. So you have to look at where does the current go through the amplifier. So the current goes through from the speaker terminals, goes through the output inductors. These will cook and overheat and short out from 30K. Then it goes through the IGBTs. There's only 8 of them. I don't know of any IGBTs where you could put 8 of them that could be driven by this circuit that would allow for 30K. But maybe they do exist, I don't know. But if they did, you could put IGBTs in here to allow for 30K at 1 ohm. But Then where does the current go through next? Rectifiers. We probably need to double up the amount of rectifiers, which we could do, or fit bigger ones. Then the current goes through the transformer. This is going to saturate, and when this saturates, it's going to overload the power supply FETs, and they're all going to explode. So no, this can't do 30k.
These amps, so many things you've got to do to get these amps up, man. It's ridiculous.
Yeah, the M21Ks are definitely some of the longer ones to take apart for sure. Here we go. So rectifiers, originally this amp had U1660 CTC, and we are putting STTH16LO6. See how these fare. Hi Steve, how's it going? Yes, 350 volt caps in this. So yeah, the rail voltage will be in excess of 300 volts for sure. Which sounds like a lot, but it's actually less than the rail voltage that you'll find in the likes of them big ass Korean half bridges that do like 12k. Because obviously with a Korean half bridge, you can have 250 volt rail caps, but the rails are obviously positive and negative, so then you end up with near on 500 volts worth of like rail to rail potential. So although it looks like it got scary high voltage rails in this, yeah, they are pretty high, but in the half bridges they're double, because you need double the voltage because it's a half bridge. Yep, this is an amplifier. What are you making? So this is a automotive competition amplifier. This is a modern spec'd up Class D amplifier. It genuinely, and this is the thing, I'm actually going to make a video on this because it kind of annoys me that people don't understand about electronics and amplifiers. A lot of people are stuck in the past with amplifier specifications, but either way, this amplifier genuinely produces 15,000 watts RMS into a 1 ohm load continuously, and it will do 18,000 watts RMS with 14 volts on the input terminals. And this one had a power supply SMPS meltdown due to shorted rectifiers. Unsure of the cause why the rectifiers failed. It's possible that they were just a dodgy batch or something, but the output section of the amplifier, the actual amplifier stage itself, which is literally just this bit here is the amplifier, 15,000 watt amplifier right here. This is the rectification stage for the from the SMPS. And then this is the SMPS, this is the power supply, which is converting 12 volts into about 300 volts. Sam, you need to see the new revision of the Big Boss 8K. They've added the PCB to the new HD10K. Really? Interesting. I got to see that. I've built speakers but never seen the inside of an amp. This is low-key interesting. Amps are pretty awesome, man, and they're not too difficult to work out how they work and follow what's going on. They're you know, once you get your head around them, they're actually pretty simple.
Not as damaged as I thought this one, to be honest. It's just a lot of soot.
Yeah, that's the thing. When you get power supply failures, the power supply MOSFETs, they just chuck out all kinds of smoke and soot and stuff, and it just coats the board and makes it look like the whole amp is completely cooked, but it's actually not really that bad.
Yeah, look,
If you clean it up, it kind of comes out alright.
Yeah.
Alright, I've got 2 spare. Pop those in the rectifier drawer here. There we go. Get these all soldered in.
But I say it's annoying because, like you were saying, Sam, how the heat sinks are soldered straight to the back of these.
Yeah, that's really jarring. What I usually do in those is I just don't bother soldering the heat spreaders, and I just fit some thermal tape or something.
Yeah. I was not actually that bendy in all fairness, considering.
Yeah, those boards are quite thick. They're not bad.
Yeah. Cool. Right, I need to get that driver card out. Are you sure this will work on this one though? This is a 20. They're different colours.
Have a look and inspect them and see whether the component layout is the same. They haven't between the variations of those amps. They haven't changed the output. The output side at all.
Oh, let me bring you guys over.
As far as I'm aware.
Solder everything. So I'll bring you guys over to the. Oh, just above the camera. Didn't mean to do that.
But yeah, just do a proper visual inspection and just compare all of the components and stuff on there. But yeah, the output side is the same. They didn't change any of that.
Cool.
Sam, is it a bad thing to run a PowerOS 10K below 1 ohm? If it's a 1 ohm version, I wouldn't recommend it. The PowerOS are pretty. They are pretty well built amps, but there's not a lot of headroom on the table for additional current. So I would advise against it. They do a 0.5 ohm version for that reason. So if you need to wire below 1 ohm, then probably get the next model down.
Erase this.
Would it be advisable to always measure the diode on the gate on blown MOSFETs in that stage, even if the drive transistors are measuring okay? Yes, not a bad idea. There's a couple of ways you can do that. Obviously, you can, in order to measure the diode, you would have to remove the gate resistor. So if the gate resistor and diode are in parallel, then you can't measure the diode because you're just reading the resistance of the parallel resistor. So you have to just lift the resistor temporarily, and then you can measure the diode. But if the drive circuit's okay, chances are the diode is as well. Like they're pretty sturdy, the diodes there. It takes a fair bit to kill them, and if that much energy's gone backwards down them, or that much current, then it's probably going to have killed the driver, which is a lot more sensitive. So if the driver's alright, the diode's probably fine, but you can check without removing the resistor or the diode by repairing the amp, fitting the new outputs, powering it up, and then using your oscilloscope to very, very carefully compare the gate drive wave shape between like one of the FETs on a bank that didn't fail. So you have a known good one. So you compare the shape of the drive wave on the gate. So it's great to have a scope where you can pause the screen, so you can hold that shape on the screen. Move your probe over to the one where you think, where the FET failed, and then start the scope again and look carefully on the screen as you start the scope again to see whether there's any change or difference between the waveforms. You can go back and forth between the two waveforms and compare them to see whether there's any differences. And if the diode has failed, then the turn-off slope will be a lot shallower, because obviously the MOSFET will be turning off through the gate resistor only rather than being pulled off quicker through the diode. So that's a nice easy way to just double check everything's okay without having to like desolder any gate resistors or anything. Just look at the wave shape.
No, I've just clocked. I am missing. I've got some in storage. The end of that, the nozzle. I've got to find it.
Nice.
I have to find it. It'll be here somewhere. Here's the other driver card for. Is it gonna focus? Probably not. No. Here we go.
Most MIG stick welders run between 20 to 30 volts. Most welding machines that people operate up to 150 amps. So technically there is enough power in a 3K amp to do average weld jobs. Yeah, so like amplifiers are not complicated. They're just a circuit that is creating a varying voltage from a set of pulses. By pulsing MOSFETs, you're creating a varying voltage on the output. Amplifiers just so happen to do that in a sine wave, because obviously you're giving it a sine wave into the preamp stage, and it's then using that as a reference to vary the duty cycle on the MOSFETs to give you a sine wave. But you don't it doesn't have to be a sine wave. You could modify an amplifier to just output any varying level of DC that you so want. Very easy to do actually. All you'd have to do is just tap into the last stage of the preamp circuit, jump over all of the DC blocking caps, and then just feed it with a little reference voltage from, like, you know, if you just had a little circuit that with a little potentiometer. Actually, you wouldn't even need that. You could just put a potentiometer on the top of the amp, and you could take a reference from like a 12 volt supply inside the amp through a voltage divider with a potentiometer, just to vary the amount of DC going into the Class D drive circuit, and there you've got basically a 0 to, I don't know, whatever the row voltage is. In this case, this amplifier, you'd have variable DC 0 volts to probably 300 volts ish, high current, DC supply for doing all sorts with, I guess. But the thing that probably differs between amps like this and welders is welders will have some kind of very, very low value resistance in series with the kind of output stage of the circuit and the kind of welding tip or whatever, so that, because when you're welding you're essentially creating an arc or like a short, and at times it will be dead short. These amplifiers don't have any protection against you creating a dead short when there's high voltage there. It will literally just blow the FET. So I imagine, I don't know because I don't design welders or anything like that, but I imagine welders will have just enough inline resistance whereby it can be presented with a dead short, and the total resistance of the pathway from the amp through the tip or whatever back again is high, just high enough that it doesn't blow whatever the output devices are in the welder. But with these amplifiers, there's actually electrically a huge difference between like 0.1 ohm and 1 ohm. Like they sound close together because of how humans deal with numbers, but between 0.1 ohm and 1 ohm is like worlds apart. Absolutely huge difference. So do Class D ICs cause the amplifier to go to protection when they fail? You can do. If it's IRS 2092, 20957, then yes. They can send a protect signal out to the rest of the circuit, which prevents the amp from coming on. If it's drivers like the 21844S or 2010s or 2113s, they don't really do that. The only time that the amp will still be in protect due to a driver fault or failure is if the driver is causing there to be DC offset on the speaker terminal, and then there's a separate protection circuit on the amp that detects DC offset, and that will then trip the protect. But the only drivers that I work with on a daily basis that can sort of output a hey something's not right here signal is like the 2092s, 20957s I think maybe can, but generally 2092s are very bad for it. Like 2092s, 2093M as well. If everything isn't perfect, if everything isn't absolutely perfect, they won't oscillate, and they chuck a protect signal out to the rest of the circuit, which is listening for it and just protects. You can make up a circuit to turn the voltage across a current shunt into an RCA feed for the amp. Yep. Right, so that is all of the rectifiers fitted. However, one last thing we've got to do before we try and power this up is it did blow the traces on the top. So if I can just zoom in real quick, I can show you. So for example here, when it failed, it popped the trace from the board to this rectifier leg here. So what I'm going to have to do is just lift these up so I've got access, scratch away at some of that trace, and then just solder some jumper bar. I think it's just on this side it happened. So
this is mad.
how's it going? Are you desoldering? I can't. Oh yeah, you are desoldering. Yeah. you want a recommendation?
Yes, please.
Do you have a big ass heat gun like this?
Heat gun? Yeah, I've got heat gun. I've got heat gun for all the different tips.
No, but do you have a massive one, like big ass, like, you know, DIY 1400 watt thing like this?
No.
Alright, damn.
Yeah.
I was gonna say, if you got a big ass, if you got
it only goes 40.
yeah, if you got a big heat gun like this, you can literally just cook up the whole back of the PCB around where those pins are, and then the drive card will just fall out.
Yeah, I know, that's how I want it. I've got it out before, that's how I got the other one out, but it's never straightforward, isn't it? I'm gonna have to scope him again. Okay, that one's now moving.
Sam, what amp is it on? Is it you're on, dude? First one with voltmeter I've seen. It's that's this Taramps HD15K. All the Taramps have the voltmeter on the front. Guys, need help for a cold enthusiastic planning to buy an Alpine Type R12 silver one used. Is it still usable today? Yeah, man. The Alpine subs, they're still absolutely fantastic designs. Highly recommended. You can pick them up really, really cheap, and they'll outperform pretty much anything else you can get for anywhere near the same price, even 4 times the price. So yeah, if you find a good condition Alpine Type R, especially some of the newer ones with the ribbed surrounds, they're actually excellent sounding subs. They play up higher into the higher kick bass range than a lot of other car subs will. So especially good if you're into sort of techno or like rock music, or like even just some acoustic music, whatever, that has more kind of energy up there in the sort of 60 to 90 hertz range. These Type Rs do play that really nicely. Hairdryer is not a shout, no. Oh, it helps a little bit, but not really. Like, hairdryer doesn't get to anywhere near the temperatures you need. Hairdryer is good for taking subs apart and softening the glues between the surround and the basket and the spider and stuff, because the heat gun will just melt.
I'm pretty sure
melt
on these, aren't they glue at the bottom of this?
Maybe, yeah. There's a little bit of glue.
No, there's not. There's not.
Do the IRS 2092 class D chip cause the amp to go into protection? Yes, with the 2092, you have to have fixed absolutely everything for the 2092 chip to come on and oscillate. So you need MOSFETs fitted, you need all the gate resistors repaired, you need all of the high side bootstrap circuit working, you need absolutely everything to be perfect. If it's not perfect, then you won't get any class D oscillation, and it will generally be tripping the amp into protect. So if you don't have MOSFETs fitted on a 2092 amp and you're confused why it's going into protect, fit some bloody MOSFETs first, and then try it, and you might find it just works.
This is going to be a pain in the ass to get up and go.
Right, let's try and get some jumper bars on these. It's just connecting to ground, so we have ground trace in front and behind. So I'm dropping some flux on there. I'm going to tin the board first, and then I've got some thick sort of component legs that I can go between them.
All the legs are free now. I just want to snap the legs. That's the annoying thing.
If all the legs are free, then you can just pull it out.
You can see it. You can see them moving on the board. Yeah.
Yeah. If all of them move when you wiggle it, then yeah, you can just flip the board over and just pull, and it's probably the glue that's holding it in now, so you can just pull it and the glue will just stretch out.
Yeah, no, I don't want to break the legs.
Why would you break the legs?
That is loose though.
If they're
I'm wiggling it, isn't it?
Well, don't wiggle it. Just pull upwards, like directly upwards.
Yeah, no, that's not it.
You can be rough with it. If all the legs are loose, then you're not going to snap any of them because they're not attached to anything.
Maybe you guys can see that. I'll zoom in so you guys can see what I'm talking about. Now, this is how loose it is. Can I zoom you guys in? Is it going to play ball with me today?
I wonder if I can give you a bigger screen. Hang on. What have we got? Scope.
Hold up, my camera's not playing ball.
Yeah, okay.
You've been doing this for time.
I realise you lost the audio. Sorry. That scene in OBS is one that I never use, so none of the audio is set up. Hang on.
It's just getting snapped in it.
Right, you should have audio back now.
This thing is hella loose. I'll flip it around, I'll show you. This is how loose it is now, guys, look.
Yeah, that's ready. Just pull it out.
Bro, it's not, trust me.
It is!
It's not, bro.
Just pick it up from the corner and just pull it from each corner. There you go. Yeah, just do it. Pull it out hard. Go. It's just the glue.
There's no glue on it, Sam.
You sure one leg isn't still attached? Are they all loose? Well then, yeah, you should just be able to pull it out. Yeah, and you can just pull it out then.
Let's flip it over again. This is not my expertise, these driver card stuff, to be honest. But it's how you're learning it. I bet if you had this, I never had it out an hour ago, mate.
Well, the tool that you're missing is a big ass heat gun. That would have saved your ass.
Yeah. Let me just make sure these are all moving. Yeah, every single one is moving. Oh. Oh, it's coming. Wait, got it out.
Nice one, good job.
Did I break it? Did I break it? No, I think it looks good, guys.
Round of applause for Mr. Sinewave02. Did you put in your vias? Probably not, you probably did it right.
No, maybe it is.
Awesome, good work.
Cool. Right, I can get this one to one side now. That's all good. Let me check the other side there. Imagine the other side's got like a big hole in the board. Let me check. Now look, I can now zoom you guys in this actually. I'll show you how it come out. Can't get far away from the... Is it gonna focus?
Yeah, it looks good, man.
Come on, focus for me, mate.
Streaming at this time of day is actually kind of dead. I just looked at the amount of viewers we got currently. Dead.
It's alright, Sam. We don't do it for the views. We do it for the community, mate. You can watch data.
Yeah.
Right, cool. I think I'll sort that board out. The other one. Nice. You better go in a new board, nice. Oh yeah, I've got to compare them, don't I?
Yeah, visually compare them just to double check.
Do you know what? I'm just going to send you a picture, innit? That'll be probably better.
Alright.
Compare it on stream. I mean, they've got the same numbers in that. But do you know what, Sam? Do you know what was about to look on there? When the amp blew up?
Right, this is a little bit sketch because on these rectifiers we're going to have some stanky high voltage, and because of the jumper legs I've had to solder because where it fused the PCB open, these legs are now a lot closer to these ones, so I'm hoping there's enough gap there. It looks like there is. It's a pretty massive gap, to be honest, and the voltage, I say it's high, it's not that high really. Like 300 volts is not that high. It's not high voltage when you're talking about like spark gaps and stuff, so yeah, this is fine. Like if the voltage on here was like 5 kilovolts, then I'd be thinking but yeah, we're fine.
I'm going to send you that picture now.
Alright, big man.
I'll send it over thingy. Tell me what you think.
Let's have a look.
I think we're good to go, to be honest.
Hello, comma, please read the listing description and follow the instructions. Full stop, thanks. I say that like 8 times a day. I've got an eBay listing that's a bit of a side hustle, and it explains how to it has all of the instructions in the eBay listing description, but people just literally message me and say, hi, I need help, can you do this for me? And I'm like, literally all the instructions are in the description. Alright, picture from Mr. Sinewave02, let's have a look. It's not quite close enough, but I can kind of make out. Yeah, the layout is exactly the same.
I'm just looking at values, innit? Because one says V20, one says V30, but I can't see any differences.
No. The only important ones really is just to double check the numbers on the resistors around this top chip here, which is the 293, I think it's 293 in this one. And also check the resistor values above the kind of 8-pin chips either side, like these resistors at the top here. Just make sure they're the same. But like it would be like they wouldn't have done any changing of that, because this driver card, they haven't really designed that for this amp. This is like a tried and tested known
Yeah.
working driver card for this type of Class D. So yeah, they'll be.
In my opinion, the only reason why this amp would not work is because the initial blowout on that donor ramp has killed this driver chip. That's the only reason why I can see it going bad. Apart from that, it should work.
Well, you had a power supply section failure. The output was fine, so the driver card will be fine. The drivers don't generally die in those amps anyway. I know that you had one where one of them did, but yeah, because the I think the outputs are buffered on those amps, so the drivers rarely ever die. So I think you're fine.
Cool. I want to get up then.
So on eBay, my side hustle is I'm selling a service to reset the parental controls on Nintendo Switch consoles. Thank you, just waiting for your order to come through, and I will process the master key. So yeah, on Nintendo Switch consoles, if you buy one that's got parental controls on it, or you forget your parental code, then you generally have to like call Nintendo and they have to give you a master key, but I've got a way to generate master keys from the serial number and the inquiry number. So I just have a little listing on eBay that just offers that as a service. Yes, you must place the order with me before I can give you the master key. Full stop. I have it ready now, I just need your order to come through first. Full stop, thanks.
Oh my god, that went in too. Hey, no, Sam, this is going too well. There's gonna be a catch. No, it's going too well. Keep at me, fine. It just went in perfect on the new one. What's the catch? Tell me it now, man. Come on. What's the catch? He's putting up solving simple, man.
I have a friend with 2 Hz HCP4 channel that got hit on the RCA inputs in a boat with 230 AC inverter. That sucks. You're going to have probably some open resistors, you're going to have some shorted DC blocking caps, and you might have some cooked op amps, 072, 072C or whatever they're using in those amps. So yeah, preamp section repair, and sometimes when you get like a big spike on the preamp, it does also kill the output section, so you might have to repair the output devices as well.
They face forward, didn't it, Sam? They do face forward, the car, didn't it?
Yep.
Like that.
Yeah, it should be pretty obvious which way it goes in based on the markings. Ah, here we go. The orders have come through. Nice. Thank you. Right. Serial number. There we go. There was your master key. Enjoy. That's my doorbell, BRB. Entertain them while I'm gone.
I'll blow myself up. Right, where is it now? Right, it's there. I can't even see your guys' comments. I need to go on the computer. Cool. Right, guys, let me get your comments up on my other phone because I can't even see what you guys are talking about because I'm not on the computer.
I was hoping that was going to be the parts for the Band of Viking, but it wasn't.
Oh, you're back. Even better.
Yeah, I'm back.
Even better.
Okay, cool. Let's put some power into this HD15K 2 ohm. This is one of the scarier amplifiers that I powered up in recent times. And for this one, I want to make absolutely sure that there is no solder beads. You know what? I might actually just put something else down on top of here, just because there is kind of a few solder beads on there. Let's put this towel on there. Yeah, I mean the 15Ks are a bit scary, but the 2-ohm versions are even scarier because the rail voltage is twice that of what it should be in a 1-ohm version. So what we're going to do is, so with these older HD series amplifiers, there is a pretty easy way. Alright, I'm going to show you something pretty cool. If I can remember how to do it on these. We've got the pull up, yeah. We're going to get the output side, Class D oscillating without the main rails present. I can't find my safety glasses. I'm just going to have to do like safety arm. I don't know what I've done with them, but I think the output section should be fine. This amplifier seemed to have failed due to the rectifiers failing. The output side doesn't appear to have any problems, but I could use this opportunity to show you how to get the output side working without the rail voltage present in these amps. But actually, I don't know if I can be bothered. I haven't got really got time. It's a bit of a quick rush stream today, so I think we're just going to go full send and plug in the power and get big ass rail voltage cooking, and yeah. Full send. So get the power wires going in there, and get the remote cable hooked up as well.
I've not used the most biggest tip to solder this, I'm not gonna lie. Oh my god.
Alright. So I'm going to keep it at like 9.2 volts, as low as I possibly can, while the amplifier will still come on and play. So I am looking for, so this is power supply MOSFET drain. So as you can see, it does the health check pulses. Now that should equate to a little bit of rail voltage built over here somewhere. Am I DC coupled? Yep. So rail voltage is getting built here on these two and these two. Rail voltage then is on the high side output IGBTs. Alright, nice. So let's get my other oscilloscope probe. What I'm going to do is I'm just going to lock the scope probes onto the amp so I can hold my arm in the way. So there's no official service modes for any of these amplifiers. Service mode is just what I call the state that you put the amplifier in, whereby you can power it up safely and get Class D switching on the output side without the rail voltage present. It's just a name that I sort of, I guess actually one of the guys that was helping me with sound digital repairs back when I was first starting doing sound digital repairs, I think he gave it that name, or maybe Sound Digital even gave it that name, but it's not an official mode you can put the amp in. There's just it's just a selection of tweaks you can make to the circuit and voltage injections that allow you to bring the output side up without rail voltage. None of it is official, really. There's no official mode for it, but you can do it with practically any amplifier. So yes, these older HD amplifiers, there is a way to do service mode. Right, so we have how much rail voltage? Right, so rail voltage is climbing slowly, so I've got two channels turned on. This top line is the rail voltage, and this bottom one is the low side drain on the output IGBT. So I'm just going to kind of fingers in ears and just stand back a little bit, and we're going to watch this come to life. Now guys, would you rather see the scope like that, or would you rather see the board? I think you'd probably rather see the board, because you can still see the scope quite well there. I think you'd rather see the board, just in case anything does go pop. Maybe lay the towel on top. Nah. Alright, so what kind of rail voltage are we going to be seeing from this guy? We're just pumping it up really slowly to start with. We have 100 volts rail so far, but probably only another 200 volts to go.
Let me inspect.
We're up at 180 volts, and we're going to go off the screen on the scope. So what I'm actually going to do is I'm going to switch over to a different probe. I'm going to go for my times 100 probe, so we can actually see what the rail voltage actually is, because it's going to go off the screen. So I'm just going to swap my probes over. Give us the X100 probe. This one right here. There we go. Tell it that I'm using a 100 probe, and yeah, now we've got 168. There we go. Now we can keep going. $205. I might need to up the current a bit. It's not really creeping up as fast as it should. Oh, there we go. Okay, there we go. We had Class D switching, but obviously the Class D waveform was off the screen. But if I drop that down, we can see it probably properly. I'm just going to increase the voltage a touch here to 9.5, just so the amp remains on. But we did have Class D switching, so that's good. I'm going to go again. There we go, Class D switching. We have 3.5 amps worth of idle current draw and off. Fantastic, nothing exploded. That's what we like to see. Now I'm just going to grab my thermal imaging camera real quick. This little thermal pro thing, it's freaking awesome. I'm just going to go over and check to see what kind of thermals, what kind of heat we had. I mean, 3.5 amps is pretty low for an amplifier of this grade, so that's pretty cool. I'm just going to have a look over to see what was getting hot. So we got wow, 60 degrees on, what is that? That's a very, very hot spot, that is. I think that might be the voltage reg. Is that this? No. These resistors? Oh, they might be the rail pull down resistors. Alright, that's fine. But yeah, IGBT is stone cold. Optimized drive circuit. Very, very nice. So yeah, in order to just confirm that that's all good, we were only at 9.5 volts there. I need to go up to freaking 14 volts. So that was the lowest possible rail voltage that this will come on with, which was I think at 220-ish volts DC. So I need to push this up into the 300s. Let me just check my guy got his master key sorted. Yeah, he said thanks, working. Excellent, good job. Alright. I didn't optimize anything. I just mean that the drive circuit in this amplifier is pretty well optimized for IGBTs. Can't always bank on them doing a good job like that. So, all right, let's knock up to 12 volts. Let's see what kind of rail voltage we get. Ah, fuck! 291 volts rail. All right, let's go up to. Oh my god! 324 volts. 345 volts. That's enough for me. Shish kebab.
Yeah,
That's like getting on for the freaking rail cap limit. That is. That's the rail cap limit, pretty much. Like the rail caps are 350 volts, and that was like 340 something, 14.2 volts. These are IGBTs, yeah. They're. The IGBTs used in this amp I'm a bit too scared to like touch my keyboard just because there's still like 315 volts sitting there, so I'm just going to use my phone. But the IGBTs used here are IRGP4066D, and I think these actually might be 350 volt IGBTs. Most IGBTs these days are like 600 volts or 650. They don't actually make these anymore. IRGP4066D. So yeah, these are. Oh no, sorry, these are 600 volt. Yeah, these are 600 volt IGBTs. So these IGBTs weren't, you know, they were only just half towards their breakdown voltage. So they don't care, they're fine. Just the rail caps were kind of getting a bit close to their limit. So these are 600 volt, 90 amp. 600 volt 90 amp parts. IGBTs are a lot more sturdy and robust, and like, yeah, they're a lot more power dense than MOSFETs are. The difference with IGBTs is they're way slower. They're much harder to drive. They come on slower, they go off slower, but they are a lot more power dense. MOSFETs are better for very high frequency switching. Yeah, IGBTs the IGBTs is what used in freaking motor controllers that run trains and freaking like, you know, high power EVs and stuff. But we still got 256 volts worth of rail sitting there. Nice. And I know that this sounds like a lot of rail voltage, but I'll reiterate that the highest rail voltage that I've ever dealt with was 435 volts rail, and that is the kind of rail voltage you see in those really big Korean half-bridge boards, like for example the Digital Designs Z2B. Digital Design Z2B, if you push the voltage up above 16 volts then yeah, you get like 430 volts DC across the rails. Scary stuff. Is it worth doing another thermal check? Nah, I don't think so. The output section is fine in this. It didn't get hit by anything, so we made a repair to the power supply. That's all stone cold. I can do that because the high voltage isn't here. The rectifiers, actually that's a point. These rectifiers aren't the original models, so it would be good just to check that they weren't getting hot. If they were getting hot, there'll still be some heat kind of idling on them, but I doubt it. Wait for that to settle. No, the rectifiers are literally not even a peep of heat. The only thing hot on the board right now is these rail pull down resistors. The IGBTs are sitting at like 26 degrees Celsius, 23 degrees over there, so yeah, it's all good.
Okay. Alright, Sam.
Yes, big man.
Alright. I've taken my motorbike helmet off. I'm gonna do it.
What from mine?
I've just tested it quickly in case it wants to mash up, but I don't want to get mashed up on camera in it. I'm gonna turn it on. I'll hold you guys down. I'm gonna turn it on, yeah.
Yep.
Build.
So hang on a minute. With this one, did it kill?
Yeah,
did it kill output FETs or?
No, it's on.
So
it
protect.
It just driver card. Yeah, it's on. So look, I'll turn it back on now. Look, I'll just turn it off.
Alright.
It's off. I'll turn it back on. On. You hear the click coming in. Click, and it's only pulling 50 watts at 12 volt.
Yeah, looks good, bro.
Cool. See that my solder job went that bad.
Nah, good job, man. Nice. So
I'm gonna test audio though. I'm gonna quickly check these FETs with the thermal camera as well, just to make sure
they do run hot.
Nothing's getting hot.
Yeah, the output FETs in these amps do run hot. You can get them to cool down. You can get them to run cooler just by running a 4148 diode in parallel with the gate resistor, because it needed that from factory that they didn't put it in for some fucking stupid reason.
Yeah. Let me go a bit high on voltage and see if I can get that current to come down. No, not current, the idling voltage. Let's go to that 14. Not sure about that.
Is that the mod you did to my other one? Yeah, so...
What should these idle at?
What, these amps? Unmodified, I think they're like... Oh, I can't remember now. 12 volts, maybe like 6 or something, 6.5 amps, something like that.
Something. 12 volt, yeah. Hold on.
So it's been a while though. I can't really remember because I always do the mod. So the mod that I do on these is I just fit 4148 diodes in parallel with the gate resistors. It's a very tiny mod. It doesn't change. It's a very small modification. But what it does is
I'm running at 4 amps.
It allows the output MOSFETs to turn off faster, which prevents them cross-conducting, which prevents them from heating up.
The driver chip is literally cold though, there's no hot spots in it.
Good.
Yeah, none of the FETs are heating up. There is one, but I think that's something else. I think that's the one on the far end. It's not like the same as the other ones. Yeah, it looks fine.
Good.
I think I'm going to try to play some signal for it and...
I've still got 156 volts worth of rail in this, so I'm just waiting for that to dissipate before I take it off the bench and drop something else on. Man, I'm hungry. Get some lunch.
Yeah, I'm hungry as well, man.
Yeah,
well, at least it's staying blunt on live. That would have been embarrassing.
I'm not going to get some lunch. I'm not going to get some lunch yet, though. I'm going to keep streaming for a bit.
Right, let me sit back down here with you guys so I can talk, because I ain't actually got you guys' comments anywhere, so I'll bring you guys over here and we can talk. Cool. At least that wasn't a waste of time. And I think what you said, Sam, as well about the driver card being buffered is what? Do you know what I mean?
Yeah, for sure. Yep.
Yeah, the old chip. Yeah, now that chip's running literally room temperature now.
I'm just going to take a resistor and dump that rail voltage to ground on board waiting.
Cool. Well, I think for this one now, I can put the other driver chip back in, but just replace that one and let's do a whole
Ooh!
house reload.
This wire has welded itself to the board from that. Spot welding 101. Hey, who is it that said that the Taramps amplifiers are welders? There you go. HD15K 2 ohm is fixed. Yep, it is indeed. So this will be for sale. If anybody wants to buy it.
I probably am going to go fix this one as well, the burnt one, because why not?
That's good to know, CJ. That's good to know, my brother. I try my best.
What do you say?
He was just saying that all the M21Ks that I've done for him, he hasn't had any issues with, so it's good to know.
Yeah, excellent. This one actually got that one actually burnt out proper. Oof.
Annoyingly, actually.
Oof. The leg on that one comes straight off.
Annoyingly, I can't actually sell this yet because when this 15K went down, the power supply side got so hot that it melted all of the clamps for the MOSFETs. Now, the clamps that this one uses, they're like a strange size. It's like doing 3 FETs at once with like 2 holes in the middle, and there are no other amps on the market that shared that same like hole pattern. So I'm gonna have to get some clamps made before I can reassemble and sell this, unfortunately. Kind of annoying.
What do you need clamp? Oh, the Taramps.
Yeah.
try to keep the room clean, guys, but whenever you're doing this stuff, it never stays clean. Look at the bed now. I was wearing the motorbike helmet when I turned it on because I ain't got goggles in it.
Alright guys, whoever is still here, there's a choice now of what I look at next. What I can do next is I can start disassembling a Sundown Salt 12 for a power supply rebuild. That's going to take a long time, so I'm not gonna be able to finish that on stream. I might be able to get it dismantled on stream. I might be able to get halfway through dismantling it on stream, but I won't be able to finish it. Or I can take a look at an Xbox Series X, which isn't usually what I look at. Here we go, an Xbox Series X.
Oh, that's hard.
That has.
Sam, is that you?
What?
You're looking at other stuff, and that is hard.
Well, no, it's just my friends. Doug's got Xbox Series X. That I think it's got a power supply section problem. It just flashes the Xbox logo 3 times, and that's it. So I was going to take a look at it for him. I have fixed consoles and all sorts of stuff before. I just don't offer it as a service because I can't be bothered. Let's be honest. But yeah, I do all sorts of electronics, ECUs and like factory motor controllers and all kinds of stuff.
No, that is sick, bro. Rate it. I rated. Right, cool. So now,
why are you angry for?
I'm gonna find some. Huh?
You said I rate.
I said I rated for that.
No, I'm joking.
No, I need to empty up one of these Ziploc bags. They put the screen in it for the other amp. You've got to sacrifice some components sometimes.
Yeah. So yeah, I've got a Sundown NS2 to look at, but I haven't got the parts for that yet, so I'm not going to bother taking that apart yet because it's just more parts to lose. Sundown Salt 12 I can take apart. Xbox Series X I can have a look at the power supply side. What else? Anything else I've got in the workshop at the minute? Waiting for parts on the Banner Viking 7K. I can try and take the transformer apart on the Zapco DSP. Maybe I'll do that. Maybe I'll do that. Well, so here we have a Zapco DSP power supply module board with what I believe to be a dead transformer. So what I need to do is remove it to inspect it underneath and have a look. I looked at this on a previous live stream recently. So I hope that the transformer's dead because we're getting the switching MOSFETs here and here are overheating the second that power is applied, and there's no rectifier diode fitted, right? So the output of the transformer should just be open, freewheeling. It's not connected to anything, but we're getting yeah, quite a lot of heat on those MOSFETs. So the only thing between the FETs, well, the only thing after the FETs is the transformer. So it must be the transformer.
Casing had a bad day, didn't it? Casing. Oh, Sam, as well. What do you recommend? So obviously with these Vibe amps, yeah, when I put it back in heatsink, what do you recommend that the thermal but non-conductive tape that I can put under the FETs? What do you recommend getting that from?
Have you put new FETs in that one?
No, I've not touched it, but
all right, in that case you don't need to.
Yeah, but it doesn't need to be isolated from the.
Well, all the MOSFETs, they have the heat spreaders on them, which are isolated already.
No, I mean, they're isolated. I mean, like the actual. So you see this blue ship. This is the one I just.
All right. So the rectifiers are the only ones that don't have heat spreaders soldered.
So they need to have that tape. Yeah?
So they need to have that tape. Yeah, but that tape should still be intact. It shouldn't be. You should be able to reuse that. It should be fine.
Yeah, I'll just take out the mashup one. Out of that case. Cool. No problem.
Ain't no problem. Oh, big man. I might be coming to see you. Maybe.
Go on.
On the... I don't know, it depends if you've got anything for me that you want me to take up with me.
Yeah, I've got all of them amplifiers and boards and that for donors.
I don't have any more space for donors. I've got a loft full of donors.
Alright,
but I might come see you Monday if you're around Monday.
yeah, I'll be around Monday.
Alright, class.
100.
Yeah, I might come see you Monday.
What we can do is, maybe we can start the...
It will be
the Taramps video.
It will be a flying visit. I'm coming.
Oh, flying one. Okay.
I'm coming down.
Do something.
I'm coming down to pick up a car, so I've got to drive it back.
Oh, fair enough.
Yeah, I won't be able to stick around for too long. It's just a good opportunity because I don't usually come down in the car. I usually get the train. So
yeah.
Just while I've got the car down, it makes sense to like load the car up with any bits that you don't want to post or whatever.
I'll find some stuff to give to you.
But if you've got anything that you want me to look at or whatever, then
you can take the 3Ks of you.
Oh, the dead ones, yeah. I'll also take that M21K, the one that's got now the dead power supply and the dead driver card. I'll take that.
Yeah. Okay.
And I'm also going to be taking the Synergy and the.
You already took it. You already took it.
Yeah, but it's at my parents' house, so I need to grab it from there.
Oh yeah.
I thought
you would. Oh, of course, yeah. You got all the subs in it there as well, no?
Yeah, because I got the train, like, so I just wanted it at my parents' house so that I could like easily like grab it if I need to, if you weren't around or whatever. So.
Yeah, no, I hear that. Where's my phone? Where's my iPhone? It's right here.
I've got a stinking suspicion that this transformer, like, I don't know. I hope it's not fine. I hope it's dead. Because otherwise...
Yeah, otherwise unwind it.
Actually, I'll tell you what. Now that I've removed the transformer, I could actually power this. No, actually, I did that already. I lifted the legs and it was fine. So, it must be... The transformer must be cooked. There's nothing else after the FETs apart from the transformer. So, it must be the transformer. But the only way I'm going to know is by unraveling it, and this is really thin wire. I do have an inductance meter, so I can use an inductance meter, that's fine. But the problem is I don't have a reference of what the inductance should be from a good working one, and there's no schematics or anything for these. So if it's not a dead short, then an inductance meter won't necessarily help. Because if it's only a couple of turns that are shorted together, it will affect the self-oscillation of the MOSFETs enough that they're going to overheat because it's not ideal anymore for whatever other spec the circuit has. But I won't know because I don't have a reference of what it should be reading. I did use an inductance meter to try and figure it out, but look, it's almost like all of these are in use. I don't really understand what this is doing. This is like, I've not seen this sort of style of transformer setup before. So we have a couple of MOSFETs here. Get my pointer. So we've got two MOSFETs here. Okay, these drive the transformer primary. So they drive pin 7 and 6. Okay, then out of 7 and 6, pin 5 and 8 both go to this inductor, which looks like it goes to ground, perhaps. 4 and 9, I can't quite tell where they go at the minute because it goes under the board, but I could use my multimeter to...
The most impressive find that I've ever seen that you do, that I would never have guessed, is when you found that short in that crown amplifier, that transformer, because that was mains as well, and you found that still.
Oh, yeah.
That was crazy.
Right. So they're both... Right, 4 and 9 are connected together. Connected to each other. But through what? Not ground. Right, well, 4 and 9 are connected to each other. 3 and 10. 3 and 10 go to... Is there a trace there? No, that's the diode. 3 and 10 don't seem to have any connection. So I can see there's no trace. 1, 11 and 2 are connected to each other. And they also share continuity to 9 and 4. And then 1 and 12, which are the last ones. 1 and 12 are the ones that are the AC inputs to the rectifier. Right. So 1 and 12, they're the ones that have the final waveform on them that goes into the rectifier here. Right. So the ones to make sense to check, I guess, are going to be 6 and 7, which are the MOSFET drains, and 1 and 12. I'm just going to check those on the inductance meter first as an initial check. Oh, bugger! Which way round did this go? Oh no, I didn't take a reference. I'm going to have to skip back in the stream and see which. I think that must be pin 1 donation. Yeah, no, notification. Yeah, so it must be there. Right. So that's pin 1 and 12.
Alright, Sam, I'm gonna have to head off, but it's been wicked.
No worries. Thank you. Thanks for joining.
But,
it's been a pleasure.
Yeah, no, thanks to you guys for watching, and yeah, no, I'll catch you guys another time.
Yep, no worries. Enjoy the rest of your day, bro. I'll catch you in a bit.
Sweet, bro. Alright, take care. Alright, bye everyone.
Bye. Alright, so let's just go side chat. Disable. Come out of Discord. Alright. So we have our inductance meter here. So I'm just going to firstly check 1 and 12. So yeah, we do have an inductance there, so it's not a dead short. 0.3 millihenries, so I have no idea, is that within spec or not? I don't know. If I check pin 6 and 7, which is the MOSFET output for the primary, we have... Okay, it's not picking up an inductance between 6 and 7, interestingly. Okay. Oh wait, now it is. No. Give it a sec. No, it's struggling to read this one, but sometimes this meter does. Like, it doesn't necessarily mean that this is bad. It's not the best. I could get out the date and DATs and use that to read it. But like I say, I don't have a reference of what a good one should be, so I don't really know if this is going to help, other than just to check whether I have a dead short or not. 612 nanohenries, but it's struggling to read it reliably. Yeah, it's resonant based, this one. There's no drive circuit here. This is all over the place. It can't really read it reliably, so I'm probably going to maybe bust out the date and dats if I've got it to hand. Which I do, very nice. Do I have a USB cable for it? Probably not. That's hilarious, Jordan. I thought this would be a safe place from hearing 6-7 repeated. I don't actually know what the reason for 6-7 being funny is, because I don't keep up with digital culture in that respect. I know that 6-7 is a meme, but I don't actually know why or what it means. There we go, USB. This is a long ass USB cable, actually. It doesn't need to be this long. Hopefully that's fine. Alright, date and dats plugging in. So now I'm just going to plug. Now 6 and 7 was here and here. Let's get that one. These crocodile clips suck. Okay, there we go. So let's open DATs. And let's do an inductor. This does not appear to be an inductor. Okay, well that's promising, because that means that the primary is probably shorted. This is our impedance sweep. The problem is, actually though, is that I think DATS is only designed to sweep between 20 Hz and 20K. So I think this is designed for measuring like audio, like inductors that will be used in crossovers. So if this inductor, like, you know, in order for this inductor to show up or whatever, what inductor is inductor is a low pass filter, isn't it? So yeah, inductor is low pass filter. So for the impedance of this to spike and skyrocket, this is a tiny little transformer. The frequency is probably going to be in the many kilohertz range, like, you know, 50 kilohertz, 100 kilohertz, something like that. And the DATS doesn't sweep up that high, so I think that's why it's saying it's not an inductor, because like you could see the impedance was starting to creep up high. So it might just be a case. Gee, I don't know. Is it? Fuck. I don't know. can see here the impedance was starting to skyrocket above. Yeah, it was whoop, but we don't go high enough. So I don't know. Alright, I'm going to leave it there. I've got to head out. So thanks for joining, guys. Appreciate you for jumping on the stream. It's a bit of a random time to be streaming, but I had some free time, so I thought it might be good just to show you guys what I'm up to. Take it easy, have an awesome Halloween, and I will see you sometime in November.